Welcome to today's webinar. This is the series where we highlight the most innovative use cases in virtual and mixed reality. And in the past, we have been showing some pilot training, some medical training, but today, for the first time, we have maritime training. And we are highlighting a very unique use case. I'm personally very excited about this one. So together with Varcus Solutions and Reval Marine Training, they have created a green screen simulation using the virtual and mixed reality technologies. And we are going to discuss how this enables more immersive training in the maritime industry. But before we get into the details, just a quick recap of who are we at Varjo and what we do. So we are building the most advanced virtual and mixed reality devices using the video pass-through technology that enables you to combine the virtual and the real world seamless together. And our headsets also have the eye tracking technology that enables you to have unique performance analytics out of any kind of training session. And then the practicalities during the webinar. So you can pose questions anytime during the webinar, and we will take our time at the end of this webinar to answer each and every one of them that we have time, and those that we don't have time for, we will then answer afterwards and send you the whole questions and answers after the webinar. But here today, as your hosts, me, Markus Heinonen, and together with me, I have Oleg Churikov, the CTO of Varcus Solutions. Welcome, Oleg, and thanks for joining us today. And then we also have Tanel Hinno, who's the chairman of the supervisory board of Reval Marine and Offshore Training. Thank you for joining. So let's get right into it. And Oleg and Tanel, could you describe a little bit about the background? How did you get into virtual mixed reality training in the maritime industry?
So basically, from the start, we got like a gigantic, fantasy and idea to create something for maritime industry in virtual reality, because I myself finished the Estonian Maritime Academy, and I'm maritime officer, and I thought this solution will be better for maritime education for all the schools in the world. Of course, it was really gigantic idea with online support, with all kinds of trainings, fire, smoke. But then basically we met with Tanel about this idea, and we understood that to make it happen, we need to make some vertical slice of it, with most of the features that are better for training, which can show why we can use at that point virtual reality and in the end mixed reality for the education. And we need to pass those first certifications on this smaller piece of the vertical slice to open the door for our solution to go wider and be more and more certified in more standards. So, and in the future, of course, we want to go wider. Yeah, we want to cover more different scenarios, possibly different industries as well, and it should be flexible. We have the plans for online metaverse-esque experiences between different maritime schools, using our simulated solution, and we want to make it portable, so it's all in one, in some sort of containers to be placed in whatever place you need, to the expo, to the maritime school, and so on.
Yeah, this is already an extremely impressive use case, and if I'm not mistaken, this is the world's first maritime simulator that's certified, which is using the mixed reality. So how did you get the confidence, and why did you decide to tackle such a huge problem as your first project?
So, frankly speaking, from very beginning, I would say we, like Oleg mentioned that we had a large, big, great ideas, but we realized that with a limited time and limited budget, we should focus on the areas of maritime training where we can gain basically as much as possible different kind of compliance confirmations, so to say, and so this is how we ended up with a decision that we should focus on training or training aspects which are first of all kind of in some way emotional for the trainees, and at the same time we should cover both maritime part of the training as well the wind power or wind industry, offshore wind industry, because this is a future, so to say. And you mentioned absolutely correctly, it has appeared that we are the first ones, because when we started the job, we, frankly speaking, we didn't think about, okay, shall we be the first one or second one or third ones in the world? But now it has appeared that yes, we are the first ones who succeeded to create the mixed reality, approved mixed reality maritime simulation. Yeah.
Right. So let's take a look at what the simulation looks like in practice.
Yeah, absolutely.
So Tanel can say about the standard we went against.
Yeah, right. I mentioned previously. So we decided, bearing in mind the limited time, limited budget, etc. So we decided to take piece of the maritime training standards or piece of the maritime training, so to say, and we decided to cover the one of the most risky operations at sea, which is a transfer of the crew or climbers or transferees from a crew transfer vessel to the wind turbine. And for that purpose, there are training standards available, both by International Maritime Organization as well by the Global Wind Organization. So anyway, we decided to take it hard. So the hardest part of this standard, so to say, and we ended up with a solutions where we or decisions that we should have a simulation where we have 3 players together, and then we started to move on. So
yeah, so basically those 3 users who are at the same time in the same room everyone has the different role. Yeah, one is the skipper, who is controlling the CTV, crew transfer vessel. Yeah, shortly CTV. So other person is deckhand, who is like playing role of more or less instructor in our case. So is guiding people through the simulation. And the third one is the transferee, the person who actually climbs the wind turbine generators to make some work there, and then in the evening goes back using CTV to accommodation vessel. So we have a kind of small room. Yeah, it's like 2.5 by 4 meters, and we have pretty high ceilings, around 4 meters height, to give this possibility to have the ladder. So From physical equipment, yes, we have the wheel control handles from the vessels. So those are like type-approved LELAS handles, like for engines, for rudder, and for the thrusters. Also, we, of course, using Varjo headsets with customly mounted hand tracking. And we're using full set of safety equipment. For example, this is like SRL that's like is placed on the ladder to keep climber safe. And of course, we have this 4-meter ladder. It's 4 meters because a person should to comply with this standard. The person should show at least like 2.4 meters of the moving on the ladder, and we have this intermediate platform where a person does like should step on and be there.
Right. So about the vessel, by the way, So in order to comply to IMO standards, so the International Maritime Organization standards, you have to have a realistic ship model. It means that the ship must behave realistically. So it means that basically ship shouldn't behave like an airplane. Ship should behave like a ship. So particular vessel with a particular characteristics, movement characteristics, etc., etc. So we have we picked a model of 28-meter catamaran, and the behavior of the vessel has been created based on actual behavior characteristics of the vessel. So then, in order to comply to standards, there should be the day and night cycles created, and weather conditions, waves, rain, fog, everything which is which we can see while we are sailing at sea. So and further about the certifications. So basically, our goal was to certify the whole simulation based on the Global Wind Organization standard by Lloyd's Register. But in fact, we ended up with much better results. We got everything certified by number of supervisory bodies, so to say, Estonian Transport Administration, Lloyd's Register, Bureau Veritas. So that's it.
Yeah. So let's take a look at what the simulation looks in action, and then we can take a closer look at some of the technical details and how this was achieved.
So right now it will start, but basically this region is like actual region in real world in Estonia on Saaremaa Island. It's a harbor named Nasva.
Except without
the wind turbine farm is not there yet, but possibly they will build it sometime soon there. So basically, we are on the board of the crew transfer vessel, and as you see, all the people you can see like real people because of mixed reality. That's good. And so like as you see, people are wearing full safety equipment on them, though. So they are wearing harness to climb up. So they have life vests. So as in the sea, they have the helmets. So everything is like compliant to the standards. We currently starting all those doing all the final pre-leaving harbor checklists and controlling all the navigational aids. Actually, yes. Currently, the real part, the physical part, as you see in the right top corner, is only the control panel, and other like monitors are all like simulated. But due to our hand tracking solution, yes, you can still interact with them, like change CCTV cameras and so on. So yeah, currently we're living harbor, as you see, like the room already has this ladder in place, but we do not see it through like our mixed reality headset. But when we attach to the boat lines in construction on the wind turbine generator, we starting to see it. So when we see it, deckhands and transferees start to prepare to climb up. So they do the body checks, which is only possible due to like that we see each other. And we're using, as you see, we're using real safety equipment. So we're using this SRL to attach to the harness, and person is climbing up, which gives like the good thing that, yeah, he still has this, muscle memory. He feels the ladder, he feels the platform, he feels his safety equipment, and he knows its weights, because it's like, it's not as easy as like just climbing up the ladder like somewhere. So as soon as like person is on the wind turbine generator, crew transfer vessel can detach. Like in the physical room, transferee, like climber, is still there, like on the platform, but he is not seen by skipper and deckhands who left on the CTV. And same like for people on the CTV, they cannot see him while CTV is disconnected from the boat lines in construction. Now we connected back, and we are doing transfer down operation. Yeah, so person is it's like at night because it's like evening. He finished his work day. So he is like also checking his safety equipment, climbing down. Deckhand is counting ladders. Now he steps down. The biggest thing here, yes, comparing to just like ordinary scenario where you have just ladder to train on, you see that under the ladder there is like at least like 2 meters height, like till the water. And you see this wind turbine generator, which is like actually gigantic, and it gives you emotion and feeling. You feel the stress, you feel a bit of the like fear. That's like okay, I can fall. And we currently attaching to the accommodation vessel. Accommodation vessel is actually moving in the water with like slow speed. So this allows us to train skippers to attach to the moving targets. So it's like a bit different scenario for his training. For training of climber and for transferee and deckhand, it's like basically the same operation. Yeah.
But different for the from the CTV handling point of view.
Yeah.
So yeah. That's the most interesting view, by the way.
Yeah. So now we see that like CTV is coming closer again, and we are almost here to get our transferee back. Yeah. So basically, here one good thing that as we talked with our global wind organization audit at some point, they say that like most of the people who go first time to the crew or to the wind turbine generator at sea have never seen this like planted to the sea wind turbine generators, how huge they are, how they look like. And like this simulation, he was really impressed because he said like whatever about like training part, yeah, it's like really good, but like just giving this emotion that's okay, that's how it looks like, how can I climb, and you understand how high you need to go if it's not equipped with the lifts. So, and yeah, we are getting back to the harbor. We are doing the mooring operation. So we are mooring to Nassau harbor, and on this our training is finished. This video is a bit cut, but basically a whole round of the simulations takes like around half an hour. like 37 minutes. So get to the boat, to the wind turbine, attach, detach, go to the accommodation vessel, attach, detach, and go back to the harbor. So it's like pretty long scenario, but it can be used to, like, train in pieces, like only climbing up and so on.
Yeah, and that's amazing how many different use cases you can train with the same setup. Just changing the visuals. You were also training nighttime, daytime. How did you manage to do the nighttime training? What did you have to change, and what were the technical challenges there?
So basically, yeah, it was like to make the nighttime training, like, because like basically nighttime training was mandatory for getting international maritime organization ship handling standards.
Yes.
Yeah, so you need to have the night navigation possibilities. So all the like lights and navigational lights and so on are working. It can be like turned on, turned off, and so on. But when we created it the first time with using mixed reality, of course, it was like super bright because we are in the bright room. So, but yeah, using like some experimental features from Varjo, Varjo base and Varjo drivers, we managed to get post-processing on our feed. So we always like adjust our camera feed to represent realistic lighting around us. So at night, yeah, your hands are darker, the weather is darker, as in real world.
Yeah, that's very, very impressive, and it definitely adds more to the immersion, because naturally the video feed has to be darkened as well if you want to experience the nighttime. So the nighttime was one of the requirements, but what other roadblocks or challenges there were for the certification when designing this use case?
Yeah. So in fact, I think it wasn't so complicated or difficult for us from that point of view, because when we started, we didn't know what kind of roadblocks we shall see. So, so from that point of view, that was very simple. So, but of course, when we moved on with the certification, first thing we realized that people who are supposed to evaluate the result pretty often are not familiar with augmented reality or virtual, let's call it virtual reality solutions, and that's why sometimes it takes for us some time to convince the people who should check the simulator. Okay, guys, let's put the headset on, and it doesn't bite. So so first, but I think one of the reasons was that we had a feeling that generally many people have not very good experiences. I mean, with virtual realities. So pretty often in the airports or somewhere in shopping malls, you can put on the headset, and you shall see pretty bad quality picture, and you get a headache and things like that. And so that was most probably one of the reasons why it takes some time to convince people. Okay, this is good. This is what has this solution with a future, so to say.
So
So what was the first experiences then when you got the headsets on to the people and they started using the technology? What was the first impression then?
First impression was, whoa. So really, is it really? So that was the first expression. Yeah.
Trying to touch something that is not there.
Exactly.
Like in our first setup, which is here, not in the Reval office, we have this green table, not like a realistic metal table. So it was like blends into the video of it. Yeah, and so that's why they tried, okay, here is the table. That was perfectly aligned with the like actual bridge table. So okay, there is table, there is table, there is table. Okay, well, it's not it's not there. It's virtual. But yeah, from development points, yeah, if we're talking about certifications, yeah, for us it was like pretty hard to make access to the simulation as user-friendly as possible. It means that like person like is voting first time in his life, like possibly second time in his life, wear a headset on the head. So basically magic should happen. So he puts it on and he sees like already like, okay, I'm on the bridge of the vessel and I can already control everything. So we had to remove every single like stopping factor, like pressing buttons, actual controllers, like everything. So you just put it on, you're there. So we managed to do most of the things like that. Only thing that was missing is like pressing the button on the headset when you need to make the eye calibration. But like as we already talked with Varjo, it's already solved for the newer generation of the headsets.
It's funny how the smallest things come hurdles when people are using technology for the first time, and when they are not sure how to operate it, that then quickly turns the whole experience to negative. So that's why it's definitely important to reduce any kind of technical hurdles for the people.
Yeah, right. So, but since according to our best knowledge, there was no any established precedent yet. So, and there are no any standards for virtual reality or mixed realities. So, I think that was our, let's say. In fact, it was in some way it was easy because the certification bodies, they had to start to create kind of checklist based on existing standards, like training standards and general standards for simulators. So from that point of view, the list was pretty long and pretty detailed, and we had to comply. We had to comply with every detail, since in some way that was a standard we have to fulfill or we have to comply with. So yeah,
we didn't want to basically like bans or like change any standards during our development, and that was like our like basically a paradigm of working, that we took the standards and we comply in every single detail. For example, this platform on near the ladder wasn't there like when we started the developments, because it wasn't in the standard for global wind organization training, and it was added during the development. Standard changed, and as soon as we knew that, okay, we started this like, okay, now we need to have the platform, because like creating like some sort of fake or virtual platform wasn't an option for us, because our main thing was to make the same training scenario as already certified before us, like in like in physical form, in this physical simulator, but to add this emotion to it, feeling that you are there, that you are immersed, which like basically gives the better knowledge afterwards, but better memory works better when you have something to feed it with emotions.
The fear of being alone on that platform definitely creates a longer lasting memory for the training, for sure. So what were then some of the technical challenges when you started to develop this project?
So for us, one of the challenges was that as we have free person multi-user experience, and everyone is in the same green room, we had to find the solution to mask out people who are behind the virtual objects, because people are always like, due to different scenarios, people are always going out of the room and coming back to the room. And we didn't want to abstract everything like with the green, bridge of the vessel, because it was like we wanted to leave physically only those things that needs to be touched. So we had to create our custom chroma keying, not chroma keying, but masking of the chroma key layer solution, because unfortunately the solution that was done in experimental feature, so it wasn't done yet from Varjo, wasn't working for us, as we have a lot of tiny objects that were doing the mass and the layers. So we had to come up just with our own masking codes. So, and yeah, XR1 doesn't have the hand tracking, and that was an issue because we didn't want to use controllers, and we want to assess everything that people do and give the interaction with the monitors and so on. So we had to do some work and come up with this good mounts for our headsets. So if you see, there's a long history of development of 3D printed mounts, because the idea of using two-sided tape wasn't so good working for us, because this European heat wave that was this year, and also due to long training sessions, headsets were getting hotter, and this two-sided tape just started to melt and fall apart. So yeah, and the calibration also wasn't done for the hand tracking by default. So we had to first, of course, play it with the values, but it was really a pain to do. Remembering that our hand tracking was falling every single hour, from two-sided tape. So we had to create the calibration solution as well for it. And actually, yeah, if someone interested, we are always happy to share with you 3D model to 3D print it, and the software to calibrate if needed. Just contact us and we'll give it. We know this pain, and we don't want it to be your pain as well.
Yeah, you're not the alone with that pain. So other customers who use the previous generation headsets had this exact same problem, and that's why we needed to listen to them. And now in the current generation, the XR3 headsets, this is actually integrated inside the headset, so there's no even need to build your custom mounts and do all this hassle of calibrating it yourself. So yeah, you have to go to the longer and harder way, but that's much easier nowadays in the new generation of the Varjo headsets.
Yeah. So, and also as 3 people are in the same room, we had to calibrate their virtual experiences to the same exact spot, and basically to make it really tiny differences between 3 users. And for that, we tried to use Varjo markers, those QR codes, but unfortunately, yeah, they give good results, but sometimes it can lag behind, and we couldn't get the right frame from it, and there was always the problem. But as we have 2 physical places that need to be calibrated correctly, is this control panel, control point for the vessel, and the ladder on the other side of the room. We had to search a lot for the solution. We tried making some calibration algorithms, and then we knew that we found on the forums of people who were creating VR arcades the solution that you actually can copy paste the white basis data between devices. So then it was pretty straightforward. We're using our database to hold the latest calibration and just setting to other devices like in runtime. So like if they are calibrated the same. And like of course, admin console is always have the ability to like fine tune it to like final millimeters to make it like seem same for all three peoples, because like from this depends the experience between them.
Yeah, that's a great example of how you can create an easier way to develop the same experience that you might think that you have to network everybody together in the same application, but instead of that, you can create each one of them have their own experience, which is just exactly in the correct position. So that's a great example of how you can solve the same issue with two different approaches, and this seems to be the easier one, definitely in this case.
Yeah. So cable management was
that was a fun part. In fact,
that was a fun part because like currently Varjo headsets still having the cable behind it, but we are looking into the future. Yes, Marcus. But hopefully it will come sometime. But so we had to make, as people are running around in our simulation, we had to like manage our cables. But for this, we were able to use actual dock leashes, like literally for really big docks, XXL size, and like just screw them into the ceiling. So like cables are running from the basically control panel of the vessel through the ceiling into the deck. So there is no time behind between them. And our cable is like a bit thicker because we're running the hand tracking USB cable as well with it. So and so like assessments, we wanted to make the experience like at least most of the checklists to be able to automatically assess a person. So it's not on the actual instructor to check if everything is works out, and not for the person to like do something and every time check. Most of the things we wanted to assess with eyes and hands. So if you do the body check, you actually do the body check of a second person with your hands, and the check works automatically. Same goes for eye tracking with the, like, for example, if you need to look at the particular place, like for example, a particular monitor, or like at least look around yourself for the like sea condition changing during like attachments to the like wind turbine generator, it's automatically assesses it. But there was a catch, so as the data that we were working with was a bit raw, it was not always like same frame information, same for hands, same for eyes. So we had to come up with solutions for it, for buffering this data, because like when you see the first time advertisements of any new sensors that is coming up to market, you feel that okay, it's working like seamlessly because you know what goes to the advertisement always. And that was for us a bit of the okay, is it working at all, like at least with the hand tracking, is it working at all? Okay, when we calibrate it's everything, and when we used like buffering, and when we set like all the right settings for optimizing it, it started to work good. But like this first experience was will it work? Will it work at all? Possibly we need to remove this functionality whatsoever. But finally we did this.
And that definitely helps to the analyzing the performance afterwards of the training, because you don't have to have a personnel looking at everything that they are doing inside the simulation. But could you tell us a little bit more about the certifying authorities and what was actually certified for this simulation? Because I think that's also interesting for the viewers here.
So as I have indicated in very beginning about that, so our first idea, in fact, was to certify the solution only based on the Global Wind Organization training standards. So, but later on, we realized that what we can do is that we can in fact get wider approvals, wider compliance, much wider compliance against very serious standards like International Maritime Organization's standard qualification standard, which is called SDCW. So, and there are a number of requirements, very serious requirements, like I have indicated previously, the realistic movement of the vessel. So you should have the physical handles to control the vessel. You should have the day and night circles represented realistically. So weather conditions like wind, waves, everything. So visibility. So failures, like you should be able to simulate for ship handling simulator the failures of the ship's engine, rudders, everything which may happen. So tricky part was electronic chart support, because standard requires to have the possibility to have the ship's handling simulator connected to the electronic chart system, approved type.
Yeah, type approved.
Yeah. So that was tricky part as well, but
yeah, we basically managed to.
Yeah.
There is like information exchange protocol for the real like vessels named NMIA, and we use this like protocol. Like basically, we made our simulator to pass this NMIA data on one of the PC COM ports. So basically, when you connect whatever navigational device, like vessel bridge integrated system, yeah, there, like navigational charts, like I don't know, like radar, like logs, everything. It will show the data that is actually going from the simulator, yeah, from what that we capture from the simulator. And that's works really good with mixed reality solution, because we didn't need to create anything. We just put the PC, which is running like type approved navigational chart, connected to ours with this COM ports, and it shows like the map, and we can see it, and we can interact with it using keyboard, using mouse, like fully supported. And that was like actually really good and interesting like solution. And in the end, like it has like even more use cases than standards needed and required.
Right. So about the global wind organization standard, it's a little bit, let's say, simpler in that sense that there are no any requirements for technical equipment. It's written down, okay, you should have a type approved equipment or approved equipment available, and that's it. And so that's why it was simple, I would say so. But anyway, like I indicated before, the approvals are right now given on behalf of the Global Wind Organization by the Lloyd's Register, and the marine module of the simulator is approved by, in fact, by Bureau Veritas and by the Transport Administration of Estonia as compliant to SDCW convention. So
yeah, that's very impressive that you have been able to certify the same solution basically for through many different authorities, and that also shows the power and the versatility of a mixed reality solution, that it can fit to many different standards and existing standards without having to change the standards themselves. So right now, after this use case, what is the next goal after you have now certified the maritime training simulator. Are you planning to make this different, do completely different kind of training? What is next for you?
So
Right.
yeah, like basically, yeah. Now, as we said, so like we have the big great idea. So we want to go wider. We are planning to like do like different small standards like around it, like in global wind organization. We want to like we want to try to fit it in the one big platform, so people will be able to create new simulations on top of our like base to make it like easier to other like simulation creators to make their own like solutions for their like particular like training experiences. And of course, like with online and so on, like, and possibly different industries, like we're looking into aviation a bit.
Yeah, and also in fact oil and gas as well, because still the oil will be there and gas will be there for sure. So
this for some time,
yeah, definitely. It seems like a very similar use case as well. So the learnings that you gather here, I'm sure they are applicable to oil and gas industry as well. And yeah, but
and of course, like we are looking forward to new connections. So possibly we can we want to collaborate with people, possibly like who wants to make like mixed reality and like this kind of training in the future, and we like, or who wants to to be a part of this this way that we're planning to do.
Yeah, I'm sure many companies are interested because great content is always needed. And as we always say, the headset is just a display device, just like another monitor without the best possible content. And you've definitely shown here that you know how to make great content with the Varjo's mixed reality headsets. So thanks a lot for the discussion today. And I think we still have around 15 minutes or so time for questions. And I see that we've already gathered quite a bit of them in the chat, and feel free to send even more. I'm not sure if we have time to answer all of them, but we'll then send them afterwards if we don't. Okay, so there is a question: what real time were you using for this demo?
What's real time?
Yeah, well, I guess this is meaning what is here happening in real time, or and what's not.
So basically, everything is happening in our simulation. Everything is happening fully in real time.
Real time, yeah.
Yeah. So people are getting to the vessel. They are starting and we're going for around 10, like less a bit, 5-6 minutes to this wind turbine park, which is like kind of nearby, and like they should have, comply with all the navigational standards. So like they should go through the buoys that are near the harbor, and then they go out. There's like wind turbine park, so they need to use radio station to inform the maritime administrator about like basically instructor, that they are entering
the whole idea of the simulation is to teach people and to train the real activities and actions that they should do. So it means that when they are taken to the when the vessel is going to wind farm, when they are taken to the wind park, when they are climbing up to the wind turbine, etc., etc. So it means that it's all real time.
Yeah,
in that sense.
Of course, we're switching times when like we detach. Like you are free to go to attach once again, but we're switching time to like just show, okay, you are now attaching in different conditions, so like at night, or possibly wind direction changed, or possibly fog came on, and that's why like the time there is changing. Of course, they were not waiting for 8 hours to like come back and take him from there
for the sunset.
So okay, so let's get the next one. So from Derek, hello. which headsets are these three guys in the demo video using? I wasn't aware that there were untethered Vari headsets, so I can take this one. So they are the XR1 Developer Edition, the previous generation Vari headsets, and then there's also a new version, the XR3, available of the same device with some improved visual quality and many other aspects as well. So you can see that there is a cable, and the cable management was handled so that there was the cable was going to the ceiling, and that's why it wasn't distracting the people that were inside the simulation. So that's a good tip to consider for others who are designing a VR experience with tethered headsets. You can take the cord and then attach it to the ceiling, so it gives you a bit more freedom to move around. So then we have Ian Fisher. Do they have different levels of training simulations for maritime training? If so, what level would this be, and what complications would there be to get the highest level using this technology?
So this particular simulator was certified as a ship's handling simulator. So the idea was to build the simulator which complies to the requirements for particular task, which is a ship's handling task. I'm talking about the marine module. So, but definitely there can be a lot of, let's say, options. Like mentioned, like Oleg mentioned, it's possible to integrate a number of different kind of type-approved marine equipment, starting from marine radars, and then you can end up with a speed indicators, compasses, everything. So basically, you can build a very serious simulator around that.
And like the solution, of course, is modular. So like adding, like basically we took like this, like basically the smallest, like not the smallest, like second from smallest standards, like for our simulator, because that wasn't our main goal. Main goal was like actually climbing to the wind turbine generator, and like. But adding like there's like whole way to full mission supported maritime simulator, but like basically you just take the blocks that needs to be added there and add it to it. So it's not like the hard way, like it's not hard to do, but the thing is like it just takes time, and we wanted to be like to try to certify as fast as possible to just know, can we go through this door, or is there like a wall there behind us?
So we had a joke that we didn't know that it's not impossible. So
it's impossible. So we tried it.
That's a good mindset to have. Then we have Thiago wants to know, what software platform did you use for this incredible project? So
software platform basically like so it's running on Windows, but we developed it on Unreal Engine. Unreal Engine 4 at that point. Unreal 4. So then we have Michael asking, how was behavioral fidelity of the CTV virtual model validated against real-world vessels characteristics? I think you touched on this. So basically, every vessel that goes like actually gets approved goes through the special trials. Sea trials. Yes. So it's during those sea trials, a lot of information is gathered. All the like circulation times, all the like acceleration, decelerations, and so on. Like there were tons of data, and basically we recreated the same trials into our simulation. So vessel was running them automatically, and we adjusted like hundreds of actual like vessel parameters to make it pass all the simulation, all the standards, like just exactly. The problem here was that our physics system is actually based on the physics, so we are applying forces. We're not like trying to run just a mathematical model, which would be like much easier. You just get like the form, well, how it should go, and like just send it through it. So like even if we change the weather conditions, it's already, the behavior is already changing. So that's how we passed. Like basically we had 2 papers on hands, like, and we could try it like in the real world, that okay, here is the real vessel and it's like trials, and here is like our trials, like try to find the difference.
It was a little bit like reverse engineering, I would say so.
Yeah. So then the next one, Martin would like to know, do you have plans to simulate the motion of the ocean on the crew transfer vessel? As I imagine getting onto the ladder will be more challenging in rough seas.
Yeah, that's a good question. And still, since we have to comply with GVO standards, and GVO standards has a highest priority of the safety of the person who are currently trained. So that's why we always have to keep a balance between safety and the I would say outcomes we wish to outcomes of the training we wish to reach, so to say. And but still we have some ideas.
Yeah,
so you can talk about that.
Basically, like, first of all, like this in real world scenarios, yeah, like according to standards, yeah, vessel shouldn't go there like to make the crew transfer operation if the wave height is more than a meter.
Yeah, something like that.
Yeah, something like that. And so like most of the vessels are having this some sort of the stabilization mechanism for it. So actually in real world, it's not moving as much. It's not moving like for 3 meters up and down.
Yeah.
But like in our, a bit crazy minds, there is some ideas of using treadmills for it. So actually like use like programmable treadmill, but we are looking like we're thinking about it, and we are trying to find like different use cases, like possibly it will be somewhere in the future.
Perfect. And I think we have time for 1 or 2 more questions. A question from Julian. Great work with the trainer. I agree with that one. Has any research been conducted to determine what other sensory stimuli are required to simulate the facilitate training, such as motion, vibrations, auditory, and what's included now?
Like basically auditory is there,
Yeah.
visual is there, right? Physical, because like our paradigm was like every single thing that is you must touch during the training is actually physical. So other things are not there, like, yeah, but like you actually train the muscle memory on the controllers, and same as on the ladder. Like vibrations, actually there is some sort of vibration, because like at least here, as like the box with the controllers is shallow, and when the subwoofer starts to make the sound of the vessel engine working, actually pretty realistic. It wasn't meant to be there, but actually it's working pretty fine, that you have the vibration in the controls, like pretty damn realistic. But yeah, we did the research, of course, and actually what we were impressed that you actually start to feel that like the floor under you is actually moving when you are moving on this vessel on the sea, because like all the other motion sensors, like all other sensors are telling you that okay, yeah, the vessel is moving, yeah. And so like you actually feel it.
And of course there is an option always to create the wind and some water spraying as well, so in order to get the feeling that you are at sea. So yeah,
and I think that we are right now running out of time. So thank you so much, everyone, for joining today for this webinar. And we still have plenty of questions we didn't have time to answer today, but we will answer them offline, and we will send you the document with all of the questions afterwards, after the webinar. And Oleg and Daniel, thank you so much for coming and present this solution. This is one of the most, if not the most impressive mixed reality solution that I've seen so far. So looking forward to seeing what else you come up with in the future.
Thank you, Marcus, for your time. Yeah, and
thank you, Marcus, and thanks to everybody.
Yeah, who came here to hear us. Yeah.
Yeah, and then also the contact information, of course. If you want to hear more about us, you can see from the varjo.com, and then more from Varcus, you can go to varcus.com, and there's also email information where you can reach us directly as well. So thanks again, everyone, and have a good day or good evening wherever you are in the world today.
Okay.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye.